In this question, we need to find out the value of this expression. Now, this expression is forming some kind of series. That means it is following some pattern, isn't it? And the pattern is, if you carefully observe at the angle which is inside the sign, 0 degree, 5 degree, 10 degree, next term will be what? Sine square 15 degree. That means in two successive angles, there is a difference of 5 degrees and it is going up to 90 degree. Okay. So in such questions, there are maximum chances that first and last terms are clubbed together and they will form some pattern. How? Let's see. So let's talk about first and last term, which is sine square 0 degree plus sine square 90 degree. First and last term. Similarly, second and second last term will follow same pattern. How? So I'm going to write sine square 5 degree plus sine square 85 degree together. Second and second last term, these two terms. Similarly, third and third last term. So third term is this sine square 10 degree and third last term will be a term before sine square 85 degree, which will be what? Sine square 80 degree. Isn't it? And so on. Cool. So here let's observe the pattern. If I talk about 0 degree and 90 degree, think about that. 0 and 90 is what? Similarly, 5 and 85. Similarly, 10 and 80. If we carefully observe, we realize that these two are complementary angles, isn't it? Sum of these two angles is 90 degree. That means these are complementary angles. 0 degree, 90 degree complementary angles. 5 degree, 185 degree, 85 degree. 5 degree and 85 degree are again complementary angles. 10 degree and 80 degree are again complementary angles. Okay. So that simply means that we have pairs over here. Okay. Pairs such that this is sine square theta. If this is theta, and this will be what? This will be sine square 90 minus theta. Pairs of this kind. Sine square theta plus sine square 90 minus theta. Every term is this. If this is theta, then this is 90 minus theta. If this is alpha, this is 90 minus alpha. This is beta, this is 90 minus beta. Isn't it? So pairs, all the pairs are of this type. Isn't it? So this is sine square theta. And this is sine square 90 minus theta. We know that sine 90 minus theta is what? Cos theta. Isn't it? So I'm going to write it as sine square theta plus cos square theta. That means this is 1. Isn't it? So this will be what? Just 1. Again, this will be what? Again a 1. Again, this will be a 1. So how many 1 we need to write? Now this is the question. This is the big question. So whenever you see such series questions in which there are so many terms involved, always calculate the number of terms. Okay. So let's calculate. Take your time and calculate number of terms. So first angle is 0 degree. So let me write it over here. 0 degree as first term. 5 degree, second term. 10 degree. Next will be 15 degree up to what? 90 degrees. Okay. So this will be 5 multiply 1. This will be 5 multiply 2. 5 multiply 3. Next will be 5 multiply 4. That will be 20 degrees. Isn't it? And last will be what? 5 multiply 18. That means there are 18 terms plus this term as well. Isn't it? So there will be what? 19 terms in total. 19 terms. That means there are odd numbers of term. But wait. What are we doing over here we are clubbing first and last term together. Isn't it? So how many 1 will be there? We just need to count. To count this, what we will do is 19. So we are clubbing two terms together. That means this 19 can be written as 18 plus 1. So by looking at this 18, there will be 9 pairs. Isn't it? 18 terms will have 9 pairs formed. Isn't it? So 9 pair, sure I'm going to have. So I'm going to have 9 such one. So how many times? 9 times 1 I'm having. But this one term, what about this one term? Which is that one term? We need to find out that one term. So whenever there are odd number of terms involved and we are clubbing two terms together, one term will be left out. Don't forget that. So what will be the one term? We need to think about it. So if we carefully think about that term, and the pattern which is getting formed is 5 degree and 85 degree, that means sum is 90 degree. Again 10, 80, 20, 70. So if I think, then what about 45 degree? 45 degree will want one more pair, which is also 45 degree, isn't it? But we have only one 45 degree in the middle. We have sine 45 degree, one term in the middle, and if I talk about complement of 45 degree, it is 45 itself. That means the left out term will be what? Just sine square 45 degree. It will have no pair. Okay. So correct answer is this only. We just need to calculate this. So 9 times 1. We are adding 1 9 times. That means this will be 9. Okay. 1 plus 1 plus 1. 9 times will be 9. Okay. And this sine square 45 degree. We know that sine 45 degree is 1 by root 2. But we need to take square of that. So the correct answer will be what? 9 plus half. 9 plus half is what? 17. 9 to the 18. 19 by 2. Okay, 9 plus half is what? 19 by 2. So the correct answer of this particular question is clear cut. Option D, 19 by 2. Okay. In this particular question, it is given that sin x plus sin square x is equals to 1, and we are interested in value of this expression. So let's write down the given information. This is the given information and this is the expression whose value we need to find. Let's focus on this. What do we infer from this statement? We infer that sin x is equals to what? 1 minus sin square x. So sin x becomes cos square x. And if I talk about this expression, whose value we are interested in, so here cos raised to power 12x. Cos raised to power 12x can be written as what? Cos square x raised to power 6, isn't it? 3 cos square x raised to power 5, 3 cos square x raised to power 4 plus cos square x raised to power 3 plus 2 cos square x raised to power 2 plus cos square x itself minus 2. Did you notice what I did? I expressed each and every term in terms of cos square x. So that now I can replace cos square x by sin x, and here we are going to reduce the degree of this particular degree of the cos as much as possible. Powers of cos we need to reduce, powers of trigonometry function. Once we reduce the power as much as possible, then only we'll be able to answer this question. So here it will be sin raised to power 6x, this will be sin raised to power 5x plus sin raised to power 4x plus this term will be sin raised to power 3x and sin square x, and this will be what? Sin x minus 2 with the respective coefficients and sign. Okay, if I carefully observe this, only this part, this is sin raised to power 6x and this is sin raised to power 3x. Can I write it as sin square x raised to power 3 and this as sin x raised to power 3? That means this is cube of sin square x, this is cube of sin x, isn't it? And the coefficients, if you carefully observe, this is just observation skills. 1, 3, 3, 1. 1, 3, 3, 1. Coefficients 1, 3, 3, 1 is nothing but the coefficients if I expand a plus b whole cube, isn't it? A cube plus 3a square b plus 3ab square plus b cube. 1, 3, 3, 1. And I'm having a cube. So the idea is to make cube out of this particular terms, isn't it? So sin square x cube plus sin x cube, that means a is this and b is this. So this will be 3a square b, that gives me sin raised to power 5x itself. This term is nothing but what? Sin square x whole square sin x, isn't it? And this term 3 sin square x multiplies sin x whole square. So this is cube of sin square x plus sin x. Alright, let's now talk about this term. So here this is just this term, the cube one, But let's talk about this one. This is nothing but 2 sine square x plus sine x. So let's write sine square x from here as 1 minus sine x. So I'm going to get twice of 1 minus sine x and a sine x and a minus 2. Let's further solve this. Sine square x plus sine x. Sine square x plus sine x is nothing but just 1. So this is 1 cube, that is 1. So 1 minus 2 is nothing but minus 1. And we have a 2 again. And we have a minus 2 sine x plus sine x. That gives me what? Minus sine x. So final answer of this particular question is nothing but 1 minus sine x. Can we reduce it further? So 1 minus sine x from this, what we can write over here is sine square x. Isn't it? 1 minus sine x from this we can write it as sine square x. So the final answer of this particular question, clear cut, option C. In this question it is given that A is equals to tan 1 radian, B is equals to tan 2 radian and C is equals to tan 3 radian, and we need to write the descending order of A, B and C. Okay. So to solve this, we need to plot the graph of y is equals to tan x, which is this, which you have already studied in your session, isn't it? So if I talk about tan x, this tan 0 is 0, tan pi by 2 approaches towards infinity, and this is pi, tan pi is 0. Okay, and we already know that the value of pi is approximately equals to 3.14, isn't it? And the value of pi by 2 is approximately equals to half of this value, which is 1.57. Cool. And here we are interested in finding the value of tan 1 radian, tan 2 radian and tan 3 radian. Compare the values of tan 1, tan 2 and tan 3. So tan 1. So 1 radian will lie somewhere around here, isn't it? Because this value is 1.57 approximately. This value is 3.14. So 3 and 2. This 3 and this 2 radian will lie between pi by 2 and pi, isn't it? So this is, let's say, 2 and this is 3. Okay. Now, if I talk about tan 1 value will be somewhere around here. Let's now talk about tan 2. So tan 2, the value of tan 2 will lie over here, isn't it? And tan 3 will lie over here. So we can see that tan 1 is a positive value. So tan 1 being the greatest value of all, that means A is the greatest value. Because 1 is in first quadrant and 2 and 3 are in second quadrant. In second quadrant, tan is negative. We can see from the graph itself. So tan 1 is positive, tan 2, tan 3 is negative. That means A being the greatest value. So there is no competition in that. But what about tan 2 and tan 3? Tan 2 and tan 3 both are negative, and I can see that tan 3 is slightly above tan 2, isn't it? That gives what? C being the second highest. And that gives me B being the third highest. Now this is the descending order which we were looking for. A, then C and then B. So the correct answer of this particular question is option C. In this question, we need to find out the range of A for which this function is defined for every real values of x. So let's start defining this function. As we can see, there are 3 logs involved. And whenever we see logarithm, what do? We take out the expression which is inside the logarithm and make it positive. So the very first logarithm is this, and the whole expression which is inside the logarithm should be what? Positive, just like this. Okay. But wait, I can again see another logarithm. This is another logarithm and this is the expression which is inside the logarithm, isn't it? So this expression should always be positive. So let us make it positive just like this. Log sin x plus a to the base 7 is greater than 0. But again, I can see another logarithm as well. This is the another logarithm, the third logarithm. And we have another expression which is inside the logarithm. So this sin x plus a should also be positive. Okay. Let's now talk about this inequality. We just need to solve all the 3 inequalities. For all values of x belongs to R. These three inequalities are true for every real x, and we need to get the value of A, the range of value of A. Okay. So let's now talk about the inequality number 1. Okay. So I'm going to replace this 0 by log 1 to the base, same as this base, 1 by 3. Okay. So log 1, we already know log 1 to the base b is equals to 0, where base is not equals to 1 and base is greater than 0. We already know this. Now I can clearly see there is logarithm on both the sides of inequality and there is a base involved which is less than 1. What happens to the logarithm inequality when base is less than 1? We can remove the log from both the sides, but we are going to reverse the sign of inequality, isn't it? So this is greater than symbol. I'm going to write less than symbol. And I'm going to write this expression, which is log sine x plus 8 to the base 7. And this expression, which is inside this log, that is 1. Now we just need to solve this inequality. To solve this inequality, I'm going to replace this one by what? Log 7 to the base 7. You already know this. Log b to the base b is equals to what? 1, where b is greater than 0 and b is not equals to 1, isn't it? So this log 7 to the base 7 is on the right hand side. Now this base is greater than 1, isn't it? When base is greater than 1, we can remove log from both the sides such that we are going to get sine x plus a less than. See, we are not changing the sign of inequality because base is greater than 1. And I'm going to write here just 7. So this is the final inequality of part number 1. And this inequality is true for every x belongs to R as per the question. Okay, let's now talk about inequality number 2. Inequality number 2 says log sine x plus a to the base 7 is greater than 0. I'm going to replace this 0 by what? Log 1 to the base this 7. Now base is greater than 1. Let's remove log from both the sides so that I'll get what? Sin x plus a greater than 1. Inequality sign is not getting reversed. So this is our second inequality, which is also true for every x belongs to R. Now sin x plus a is greater than 1 and third inequality says sin x plus a is greater than 0. If something is greater than 1, it is anyway going to be greater than 0, isn't it? So I'm going to remove this inequality. This is useless inequality. Okay, so we are getting two inequalities. Sin x plus a is less than 7 but is greater than 1 for every x belongs to R. Let's talk about this inequality and this inequality separately, such that 1 is, or rather sin x plus a is greater than 1 and sin x plus a is less than 7. Okay, let's talk about this. If I talk about this gives me a is greater than what? 1 minus sin x. And here, a is less than 7 minus sin x. Okay, so we already know that the sin x, the range of sin x is minus 1 close to 1 close, isn't it? So let's talk about the range of 1 minus sin x to get the value of a. So here the range of 1 minus sin x, if I substitute sin x as 1, what I'm going to get is a 0. If I substitute sin x as minus 1, what I'm going to get is a 2. So here the range will be 0 to 2. A should be greater than something which lies between 0 close to 2 close, isn't it? A should be greater than something always. Don't forget this. This is true for every x belongs to real. So A should be greater than always this interval. So safe side, we are going to take this. A should be greater than 2. If A is greater than 2, then no matter what the RHS of this inequality is, this inequality will hold true, isn't it? So A should be greater than 2 is what we are getting from this inequality. Let's now talk about this. So here we know the range of sin x minus 1 to 1. 7 minus sin x is what? If I substitute sin x equals to 1, I'm going to get 6. Sin x equals to minus 1, I'm going to get 8. Okay, so A should be less than some expression whose values lies between 6 to 8, both sides included, isn't it? So A should be less than this particular thing always. Let's not forget this, always. Since A should be less than this always, A should be less than the minimum value of this expression, which is 6. So if A is less than 6, then no matter what value of RHS you put 6, 6 point something, 8, 7, 7 point something, anything you're gonna put. A should be, A is less than 6. This inequality will hold true for every expression, for every value of this expression. Okay, so what we are getting from these two inequality, A should be greater than 2 but less than 6. This gives me A as 2 to 6. A belongs to what? 2 to 6. Isn't it? So option A is the absolutely correct option. In this question, it is given that in a triangle ABC, tan A tan B is equals to 3 and we need to find the value of cos C by cos A cos B. So here is the given information. Tan A tan B is equals to 3 and cos C by cos A cos B is we need to find. Okay, but one more information which is given in the question is ABC is a triangle that gives me A plus B plus C is equals to pi. Isn't it? So what I can see over here is the given information is in terms of A and B. But the question is asked about C as well. So why not convert this C and get the complete expression, this expression in terms of A and B. Let's do that. So cos C can be written as pi minus A plus B. So this will become cos pi minus A plus B whole upon cos A cos B. What do we know about cos pi minus some angle? Let's draw ASTC. Over here, where? Okay, here. ASTC, this is pi. Pi minus something will land me in second quadrant. That means I'm going to get a minus sign of cos of this angle A plus B. So this is cos A plus B whole upon cos A cos B. Let me write this over here. Yes, minus cos A plus B whole upon cos A cos B. What do we know about this? Cos A plus B. By now, you must be remembering this formula. Cos A plus B. And cos A plus B is nothing but cos x plus y. Cos x cos y minus sin x sin y. That means cos A plus B will be cos A cos B minus sin A sin B, isn't it? Whole upon cos A cos B. Let's separate the denominator one by one. So cos A cos B whole upon cos A cos B is 1. That will give me a minus 1. And this minus will be a plus. And this will be sin A sin B by cos A cos B. That means tan A tan B. Now we just need to know the value of tan A tan B. And we already know the value of tan A tan B, isn't it? This, which is 3. So the final answer of this particular question is minus 1 plus 3. That is a clear cut